Good morning, good day. February 15, 2021. This is your friend Engineer Suraj Singh speaking from Bharat, India, addressing this talk to globe people, globe community about engineering, construction, and related topics. Engineering and civil engineering and all other engineering which are applicable, which human uses for its development, for its survival. Civil engineering, which is my profession since beginning, which has been, is nothing new to human being. Nothing you can say that exists physically, artificially, as a product goes beyond ambit of civil engineering. Civil engineering, I think, applies everywhere in our life. There is no place which can be called devoid of civil engineering. It's not that I am advocating civil engineering because I am from civil engineering community. It's not that actually. This is a fact that civil engineering exists everywhere, and we must respect that if we construct something, it is because of engineering. Civil, if we make some project, you can say major part of that project is dependent on civil engineering. And also, if you work somewhere, you sit in some building or some place, that is civil engineering. If flight takes off, it takes off from a product of civil engineering. And also, most of your time you use civil engineering product, whether you work in office or you work at home, or you stay in office or stay home. I don't think that you can call it civil engineering jungle whole life now. Before it was called jungle, forest of wood. Now it is civil engineering jungle, civil engineering coordinated with all other engineering, or you can say related to all other engineering for its functioning. Service to civil engineering is provided by many disciplinary engineerings. There are so many, not one, not two, electrical, mechanical, electronics, or you can say so many more. Now computers, IT, and we use services freely given by superpower, and that is God. We use those services, all five elements, as we believe in, and we don't only believe in, we use them, and we know what those are: air, water, skies, sun, soil. These five elements which we consider human body is composed of elementarily, basically, without which we cannot survive. So it is civil engineering and health actually that relate to each other. If my health is not good, I don't feel good, and I find it uneasy to live, uneasy to enjoy life. So it applies to our structures also, which we use for our functioning, for our activities in life. And these may be our buildings, residential buildings and other buildings, our infrastructure elements, components, our travel elements, whatever we call. Actually, we can say engineering plays existence role. Engineering contributes to existence role, and that role cannot be left undefined. Engineering, which is in fact use of mind, with I consider use of mind, and whatever we think is we do, if we bring that down to ground, whatever we do, bring that down to ground, we can say in fact that is engineering product. So engineering starts from mind. That's very much imperative. Think, again I say, it is nothing very new. Think is unit of life, unit of brain. Main purpose of brain is think, And I think maybe maybe people don't accept this, but every structure does service based on thinking capacity. We know that it cannot think, but it has forces. Whatever materials we use in structures, it may be stone, it may be brick, or it may be concrete, or reinforcement steel, or whatsoever, wood, aluminium, whatever materials we use in buildings, every material has got certain properties, certain relations in terms of material sciences, and these have certain strength. These materials have certain bending properties, certain compressive properties, certain brittle nature or something like that, and these can work in many fashions. Accordingly, these materials are used in structures depending upon requirement. But structures are structures, they have their own world of functioning and their own world of performance which we cannot note. Though we use all raw materials or original materials, you can say natural materials, rock pieces, rock dust, stone dust or river dust, river sand or stone sand or soil or water. We use all such materials for purpose of construction of our structures. Whatever sort of structures these may be. Structures are structures, and we know that forces, which we call force, means action. When we walk, we apply force and we walk. When we stand, some static force is applied and we stand. When we jump, some force is applied and we jump. Same way, when structure, if we consider I can say entity, if we consider structure as a useful object or useful end user purpose solution, my English is a little different, so I'm just trying to explain it sentence itself. When we consider structure as useful our life, it is useful because it can sustain certain forces. That material which was taken out from earth body, that material has been so recomposed by our engineering means that these materials from one atom, one element, one mineral, one particle to billions and billions and trillions of particles are connected together, joined together in certain fashion, so that this component which we produce is able to sustain some loads, some actions successfully. These forces may be whatever nature, tensile nature, compressive nature, or you can say bending nature. These are very important properties, compression, tension, and bending. Compression, we call this, you press something, it is compressed, pressed by whatever means, and if you pull something, it's called tensile force. So if you subject some object to compressive force, it's pressed down, and when you pull it, it's in tensile action. Or when you just stand on something, it will come down, and that's bending action. So I'm just telling you these three important properties: this compression, tension, and bending. These properties actually are very fundamental in nature, and based on these properties, various stresses are generated in materials, and these stresses are taken care of by engineering. If something bends, it doesn't mean it will bend in reality. Its bending shall be controlled. That's what is engineering about. If there's some compression, it tries to press that structure, and we have to provide resistance to that pressure of compression or of tension. This is what we do. There's some movement, and we control that movement. When I talk to some people, means people argue about, means, oh no, we want this type of building. I say, no, you don't understand what building is. In buildings or in structures, we have to see that whatever movement of building acts, movement of a structure happens, we have to control that. That's what engineering is about. But those people, common people, do not understand this fact. Oh, they say, no, the building is standing and it's okay, fine. They don't understand the building moves. They don't understand building moves in all three directions: horizontal direction, vertical direction, or you can say in diagonal mode. It moves from one location to another location, but though it sets wherever it is. They do not understand that structure can sink as well or can sway, these people, because they don't have that detailed knowledge. But this happens. I explain many times. When you stand on some bridge of railway, when train passes below, you feel vibration, and then when train leaves away, goes off and passes off, you find that those vibrations are gradually down and to zero non-existent. That's what building does. Whatever structure you stand on, don't think that this is only a structure. You have to think that this is not a structure. This is a live structure. Means it's not that it's structure. Oh, this is building. This is done. This doesn't go anywhere. No, it can go. It can go to somewhere which we do not know, provided it is not properly administered. It is not properly engineered. So whatever structure we do based on planning, based on design, that is called engineered structure or professional structure, you can say that. Where professional applications have been applied, where professionals engineering applied on that, was applied on that, and that's what you say. This is, you can approve, or you can say this is a design structure. There are so many ways. Means if you just blindly construct some building and based on your experience or your convention, without even designing, building won't go anywhere. That is right. But when it goes, it shall not provide. It shall not submit to you certain application that sanction me. I am going to move. It doesn't happen because it works on its own. Building is not very light. First of all, we have to understand structure is not very light. We do these days generally in common reinforced concrete. Reinforced concrete, you know what is reinforced concrete? Reinforced concrete means a concrete material which is production of various ingredients. That's called concrete. Concrete means that you have to mix cement with many materials which are not reactive together. For example, stone aggregate or stone chips with various properties, inheriting various properties. Stone dust inheriting various properties. Stone dust in many, you can say, various combinations or grading, we call it in engineering. And similarly, you can say that cementing material which we call cement. Cement is only a verb. It's a kind of a property, which means cement means that two materials which cannot combine together, which cannot work together, or which cannot mix together. We use cement material to cement them, to keep them intact into one another so that they do not separate. That's property of cement. So cement is one. Cement itself is very complex in its composition, but let us say at this moment it's only cement, which is combining material of these two ingredients, which are stone chips or stone aggregate and fine aggregate, which you call sand or stone dust, and of course water is mixing agent for them. When cement chemicals come into contact with water, chemical heat is generated and chemical reaction happens, which chemical reaction forms a gel and chemical reaction relate together, and then after chemical reactions continue and it's over, we find that these ingredients both have become harder and harder and harder and harder, and this, you can say that this is concrete. Well, there is much technology behind that. That's I'm not discussing now. I'm just discussing very elementarily that this material concrete, this has certain properties. Concrete, which we say it's like artificial stone. We have a natural stone which comes from rock, and this is a kind of rock which has been made of rock pieces itself. Means rock pieces. Stone aggregate comes from rock, and also dust comes from rock particles by abrasion together. So indirectly, this is same material which was in nature, which is taken off from nature for purpose of construction, and now after construction it has become same product, but it is not natural now, because natural product has been mixed, natural products have been mixed and produce a kind of a product which is useful for certain purpose. Purpose is that concrete, we say it can resist or it can take very good compression forces. But question is, compression force doesn't work alone. Compression force doesn't work alone. When you walk, you suppose you stand, you feel some compression in your body, and that force is okay for concrete. But problem comes in when there's a tension force. You can say this material is subject to tension, and that tension, concrete is very little property, very small property it has to resist tension. For that purpose, what we do in construction engineering and civil engineering, that we provide certain other material which can resist tension. And history says that steel is good material. Steel is good material in tension as well as in compression, but steel cannot take compression like concrete take. So what they did, engineering history devised a mechanism that steel was converted to either rolled steel joist or structural steel members, or steel reinforcing bars. Reinforcing bars, which you call steel saria in Hindi, we call it, or rod, people call it rod also sometimes, but it is steel rebars, reinforcing bars, which have been produced in a way that when there is some movement or expansion, properties of steel and properties of concrete are almost equal, same, both when mixed together. When steel is provided within concrete mass, steel conducts in such a way concrete conducts in, as far as movement of materials are concerned. And that's only purpose that steel bars are used, not plastic bars or not wooden bars or something else. So steel bars, which we call steel reinforcement. And why we call it steel reinforcement? Reason being that there is a deficiency of tensile forces in concrete materials. So to reinstate, or you can say replenish that deficiency of tensile forces that concrete cannot resist tension, we provide steel reinforcement, and that's only purpose we call it reinforcement of tension. Means that material concrete is enriched to augment its property of tensile forces, tensile resistance. And that's why, so concrete and steel when put together, it's called composite, a kind of composite behavior material. And both forces, direct force of compression as well as tension, can be resisted by this. And also when tension can be resisted, compression can be resisted by this material, we can use it for purpose of bending also, because in bending both forces are created, both forces are applied. We apply both forces, compression and tension, and this application results in movement or deflection of body of concrete. And then we have to apply various methods to contain that deflection. This what we say ours is about. Very generally I'm talking. So that's purpose of we use, and this is very basics of a structure. Now there are so many ways how it is done, how it's done. There is design part, what are the metals we use, pre-stressed concrete we use, like that, and then combination of various other metals we use. We use our this block work or brick walls also, where still sometimes used. That's different purpose. But original we say is structure is in general is used of RCC, that's reinforced cement concrete, and that's main purpose. And also how it used, why it used, and what we think about that is another talk. This is main purpose, and a structure is then created, and that structure can be advantage of concrete is that it can be molded to whatever form, and that form is designed one, because whatever form we take, whatever form we do, that form should be balanced one. It should be balanced in the way that whatever forces are applied on that member, uh, these are these are taken care of by member itself, and everything remains in stability. And that stability is very important. Whatever stability we say, structure is stable or not stable, when it is stable means it comes back to its original state, even after being impacted upon by various forces. And that stability, and it doesn't change. There's no permanent change, there's no permanent deflection. Even if there is deflection, then until force is removed or force is dampened, it comes back to its original position, or there may be little deflection permanently, and it comes back to most of the deflection comes back. It's called recovery. So that's another part of view. But now I'm talking about construction issues of RCC. RCC, you know, it's a material that needs attention, that requires concentration of attention. Actually, it's very big technology nowadays. It's been very developed. There was a time that people, they don't know much about concrete, but now concrete is well known. But people who are not very well educated in profession, or they are only type of people who can work on their own sites, they only know about site work of concrete. They don't know theory of concrete or philosophy of concrete, or how can concrete behave, how can its life be enhanced, how it can be made further durable, what best service can do. Means profession is not considered in concrete, where it's very much professional material, because concrete can work for you for many decades, and even it can cross centuries. Concrete is such a material, and it's economical one. That's another point of view. The concrete is very economical material if you compare it to others, because size of members are reduced because of concrete and reinforcement. Previously, if you remember, you might have seen very old structure. Walls used to be very thick, foundations used to be very deep and very big. Those those were days when there was no technology of concrete. You might have seen many old structures like Delhi Red Fort, or like you can say your own houses. Maybe you have old Havelis, where I have seen my own house, my building where I was born. I was having about 260 centimeter walls in that. Nowadays, you find 60 centimeter wall in your building. Hardly you will find one brick wall that is called 9 inches, or is 22.5 centimeters thick, or you will find even half brick that is about 111 centimeter. But those are not, you can say, actually structural elements. You may use them for structural walling, but practically speaking, those are simply walls, and these are based on certain old system of footings. But concrete has changed entire scenario, because name itself is concrete, and we consider concrete equal to something very solid. And you know, weight of concrete, density of concrete is, that is 2500 kilogram per meter cube. I am talking in meter cube because it's simple to understand and write. So when it is 2.5, or you can say tons, 2.5 tons per meter cube, which means it is more than 2.5 times weight of water. Weight of water is 1000 kilogram per cubic meter, and concrete is 2.5 tons, or 2.5 times weight of water. So this is direct difference. Means if you use water in structural mode, you will find concrete there, and concrete is 2.5 times heavier than water. So it's a big issue, because we are slab under which you are staying, you sleeping. That slab is very heavy. You never ever realize this. That maybe your slab is say 150 or 6 inches thick, but how much load of that slab? That load, I can say only its load, because there is a slab which is 15 centimeter thick, and maybe there is 5 centimeter more flooring on that, which is generally considered concrete equivalent. And if you say concrete is there, or even tiling is there, almost the same. So you can say 20 centimeter or 8 inches thickness of weight on your, when you sleep under that's the horizontal load. Horizontal means horizontal slab, which is like thin, very thin element, in comparatively its size, dimension, you can say length into work may be more, but thickness is very limited. But even then, it's very heavy, because if you consider load of, let us say, 20 centimeter, this means 20 centimeter means it is 1000 kilogram, you can say, I'm sorry, it is 2.5 500 kilogram. 20, when you say, it is 500 kilogram per square meter. So actually direct load of per square meter, I am saying per square meter means 1 meter by 1 meter slab area, and then it depends upon how many meters length and how many meters width there is. So whatever load comes, that comes from slab, or people usually call it linter in our country. Well, it doesn't make any terminology defect, but slab weight, slab force goes onto beams and then onto columns. So you should realize means how much weight you are resting under. It's not paper weight, it's not water weight, it's heavy weight. Means you are safe. You are not going to, face any problem from that weight, magnetic attraction or gravitation. But that all those forces work. Means this slab tries to come down on its own, but it is stopped. You got my point. This slab under which you are living, we call roof. You may call roof, or you may call whatever. When you sleep below that, you use it. It tries to come down, but it doesn't come down, because it has been restrained. Restraints from its dimensions, from its edges, and that restraint is by columns or by beams or by whatever method you have provided. Those movement of or coming down, you know, style or coming down a try of slab fails. This slab tries to come down, but it cannot come down, because provision is made within that slab, and that can be steel. And thickness of slab, thickness also is used for purpose of resistances, and steel is used for various resistances to resist various forces. So slabs remains intact, and that's why it doesn't come down, and you are safe. And that load when transferred to you call them beams, and these are actually beams. And beams are, again, beam also tries to come down, but it is also restrained by columns. So you can say there's mutual action between beams and columns, as well as, columns, beams and slab. And this combination of these are type 3 members, you can say: slab member, beam member, and column member. Beams and columns are main members which directly take forces from slab and other forces from wind, and you can say thermal attack or whatever. These members work together. They are so well united that they help each other, they contribute to each other, and we say this structure is stable. Stability doesn't mean anything else. Means whatever you produce, whatever you construct, that construction should not fail. If there is a force on slab, immediately there is a force on beam, and immediately there is a force on column. So all these members, vertical, horizontal, this dimension, that direction, this direction, these members work together, and that is called stability. If this stability is not maintained, there will be disturbance among these. Unity is gone, and then there is a movement of this structure, and that movement is very important to understand, which we do not understand as common people. It's very very difficult to explain to them that in engineering it's not simply that we consider column and beam or slab and so okay, it's movement, how, what way this whole members of building. I'm not saying one member, I'm not saying that, I'm saying all members of building shall behave. That's where point lies in, important point. And that point is really very much, you can say, we cannot, you know, we cannot go beyond that point. That point is very much critical of its existence. That point is very much significant. That is very basic point which is taught in engineering. Without understanding this point, we cannot understand engineering. If I tell you there is a beam, it bends, you shall not believe, right? If I say this is a column, you are saying people call it pillar, okay? There's a pillar, and I say it can move. Is what is talking? How can it move? That's the point here. If I say there's a brick wall or there's a stone wall, it moves. People shall not believe because that movement is not visible, and that's right. Because when we do design, we stop that. We prevent. We can say a kind of preventive action we take in design. So design is a kind of preventive action. Just like we take preventive action against fire, it's kind of preventive action that we prevent this member from being affected by those forces we consider to have design. Tension force, compression force, bending force, seismic force, wind force, thermal forces, and like that. And also, material keeps on changing its properties in long duration, long term, long span, and whatever stone chips we use today, it does not guarantee that same property it will retain forever. So there are aspects of design. So why we call design is very much analytical. But before that, we have to understand what people can say about that. If my building doesn't respond to what I contemplated during design, it doesn't matter that building shall collapse. It doesn't matter that. Yes, it shall perform some other way, maybe whatever assumption I made or whatever code says, uh, that must be done, but it can be sometimes different because of so many reasons. But stability should not be out. If suppose there is some motion, some movement, you can say, if you cannot, I cannot factually understand what is motion, movement, you can say, building moves, say horizontally. I mean to say, as a whole, it is little moved. Say it moves by, you can say, 5 millimeter or 10 millimeter, and then comes back. This is the wind force. So for example, very heavy wind, 120 kilometer, 140 kilometer per hour storm is there. So naturally, your building has some height, and if your building has adequate height and it has adequate sizes in the elevations, it would register accordingly force of storm. If say it's very slender, I mean to say its dimensions are, plan dimensions are very small, but its vertical dimensions are too high, you can say, like tower we say. And generally wind force starts acting if you consider the size of your wind source. Horizontally your building is of size, let us say 20 meter or let us say 10 meter. So let us say 20 meters or 10 meters, wind shall start affecting on this. And as higher building with lesser sizes, lesser horizontal dimension, is not very good in responding to a wind behavior. That's point means slender. I mean to say, what is slender? You have to understand. I'll explain to you by this stick. Just a minute, please. What is stick here? I can't show you that stick. That's no problem because camera is not on. Well, I'm sorry. So if you take, for example, electric light, street light, there's a precast pillar below. If you say height of that pillar is much more than its size, its dimension, horizontal dimension, and that's why it's called slender structure. A slender structure means it can move frequently from its stability. It can be disturbed. But if you say plan of building is quite good in size, let us say one size is 10 meters by 10 meters and its vertical height is say 4 meters. So you can say planar size is enough, and height is not that comparatively If you say 10 meters and 4 meters or 3 meters, in that case wind effect may not be that much. You got my point. Means wind effect is not that much. It affects more on very thin structures, very slender structures, you can say. This is our language I'm talking. Or very, if you take a wire in your hand, or you can say, and try to bend it, it will bend. But if you take a steel rod in your hand and you bend it, you won't be able to bend it. If you take a timber piece, a timber long piece, and bend it, if it's thick, you can't bend it. If it's thin, you can bend it. It's like that. So, your structure, this all structure I'm talking, just to explain to you what actually structure is about. People do not understand what structure is. For them, everything is a part of building. No, there is a difference. One is part of a building which actually takes load, which receives load for further transmission, whatever it could be, and at end it goes to soil below foundation. So other is giving weight, means let us say finishing items, for example plastering or rendering. Rendering means external plaster, we call it rendering. Internal plaster is plaster. Or tiling, you can say tiling, or flooring, or your wooden doors, steel doors, aluminum doors, or whatever other items. All these items which called finishing items, these items are not structural oriented. These items cannot take any load, but these items give load to structure. Structure sustains loads from all finishing items or architectural items. You may say decorative items. You may have only 2 items in structure or 3 items in structure, but you have plenty of items in finishes, in your architectural work. So you can divide structure into 2. One is decoration, aesthetic, or you can say elevation, or whatever you can call that. Other is structure, which is only part that keeps your building intact, keeps your structure intact forever. So you can remove window, you can remove door, you can remove your almeida woodwork, or you can remove plaster, do it again, and same way you can remove every finishing item and do it again. But you cannot remove structure and do it again. If there is a use of structure, beauty of structure, that's very helpful to humanity. As a problem also, if you want to remove concrete, it's not possible without demolishing it. That's only drawback. Just like you can remove plaster and do it again, or you can remove your window and do it again, you can remove your cracked flooring and do it again. For concrete structure, that is not probable, that's not feasible. It is once it is done, once concrete gets strength, it's demanding actually. You cannot touch it. That point people don't understand. You cannot touch concrete after it serves, or it is in full service. It is in full service of humanity, and you cannot say once it is constructed and it comes into full force, full action, then you cannot touch it. And before it is done, you can touch it whatever way. You can take whatever, you can apply whatever necessary precaution during mixing, during laying, during casting. But once it is born in its own youth stage, you cannot touch it. That's the only difference. So structural items and architectural items have, you can say, vast disparity, because architectural items give force to structure. Structure takes these forces, these loads, but structure doesn't transmit any load to these items. So these items are of secondary nature, or you can say These items are for purpose of protecting concrete only and for purpose of using covered area. We sometimes people say apply plaster onto concrete surface. So I don't recommend it, but no problem, you can do it only from protection point of view, cover point of view. You may say that there will be water ingress, moisture ingress into concrete, and to that moisture may cause damage to concrete. And that's very important point, that moisture may cause damage to that concrete, and to protect that we do this. We means take such measures uh, from that. These measures are very important one. So I can say that I can say that concrete is something independent of architectural items. Concrete is something independent of your control. Once it is affected, and it doesn't listen to anyone. That's the command of concrete, that it does not listen to. It doesn't listen to anyone. Yes, you may explode it, you may hammer it, but you cannot control it. You cannot take out steel from concrete. You try to take out steel bars from concrete, it's not going to happen. It's so much bonded to concrete, and concrete so much grips steel, that you, even if you try, you won't do that. And that's called power of concrete. And concrete is not simple concrete. It is, universal type concrete, means whatever shape you want to give it, you can give it. Whatever, power you can, or you can say howsoever you want to use it, you can use it. It serves you, but it serves you according to its properties, not according to your intention. And that's what design part is. What do you understand by properties? How can you use the properties to best? You cannot even stress one material full. It's not like that. If you want to stress something, these two materials have to be in proportion to each other. You cannot say I have stress full. You can't stress full. You cannot use full resistance of steel or resistance of concrete. There are certain provisions you that we have to follow. You can say there's some instructions that you follow about these materials in codes. You know what codes I'm talking of. It's like American code, English code, or can be a European code, it can be Indian code, or whatever it is. We have to follow those, and that's where this is away from public knowledge. That there are codes to follow, there are rules you have to follow, and what you see on site, just put some shutting and steel car. That is layman job, because that they do without having any knowledge of we can say any knowledge of concrete. So concrete is very different material from viewpoint of understanding. Public only knows what is mixing of concrete and what is laying. They do not know what is behind that. People do not understand what is concrete, and that's the only purpose, that concrete understanding has to be created. Of course, engineers know it, but engineers also ignore because public ignore. For them, it's just concrete casting, and they do not know anything else. But there is a lot behind that. That's what others we have to think of: seismic action, earthquake action, thermal action, heat action. These are all actions. Just like we walk in sun, building is already in sun. You got it? When I walk in sun, it's 40 degrees temperature. How do I feel? And when we walk in cold, so 0 degrees or minus, how I feel? How do I feel? So if I feel that, and I am also composed of natural materials, including my soul, how I feel means my soul feels that. So what structure feels when it's all time in all weather conditions, that point has to be understood. You may be inside building, but building is not inside building. You got the point. I am sitting in building. I am getting protection to my body because building has encased me. Building has housed me. I am in this encasing, and forces appear. Forces are imposed on on my building I'm sitting in, and this adverse effect, as much as possible, this structure provides to me, and I got very little action of forces. But structure is always prone, always imposed on by these forces: wind force, rain, sun, storm, or whatever. So I am getting protection from those conditions, adverse conditions, from or through my casing, my housing, or my, you can say, building. This point's very much important to understand that building always serves you. You do not feel that it's serving, but it serves. That's very important point, which of technology demands and says. But these points are not clear to people. That is the point, and it's not people will understand. Even now I'm telling, they will not understand because it's natural. It's not your field. And you're not feeling any unhealthy situation in this case. You're not feeling that you're unhealthy. You're not feeling, you lost comfort. Means as far as you are okay, you are living, you are owning that building. You feel happy. I'm owner of this building. I'm user of this structure, and you don't worry about structure. You worry about tiling. You worry about flooring. You worry about paint. You worry about all decorative items, which you think this is building. That's only difference. Means you are worried about your skin color. You are worried about your beauty. You are worried about your facial. You are not worried about your bones. That is only difference. But remember, when there's a fracture or something like that in your body, it's very difficult to digest. Same is applies to building. What do you feel about building? That's just way. How I feel about building. That's the only point we have to understand. So I try to tell you about concrete in very simple term, very simple term, because ultimately your structure depends on concrete, and even if you use structural steel, you use structural steel in your building, structure steel can be used only in industrial cases, or cases where you know your RCC is very expensive, and RCC happens to be heavy, and industrial structures are not that heavy. But even there, if you go to for foundations, in foundations they use concrete itself. All the machine foundations, heavy machine foundations, are of concrete, and you can therefore say concrete is very much part of structure. You see these flyovers they construct, even they use precast elements, but foundation, or you know these columns or pillars you call them, abutments and pier, they all are constructed by concrete. So concrete is, you can say, a kind of anatomy of every structure. Anatomy means build up in a way that forces are to be sustained, forces are to be digested by structural elements, and digested means it has transferred, transport digestion and successful transmission of these forces, compressive force, or you can say tension force, or bending force, or shear force, or whatever forces come in or imposed on a structure. You impose them. You impose means you force them onto structure, but your structure takes them and transfers them to further below. And we should really understand this way, that if we do not realize, we realize now that structure is a structure and soil is soil. You see, this heavy structure, as I said, if you consider weight of your building, you may not find it, right? You may not know it. There's no way bridge that can be used for this purpose. You can only you can say you can only calculate based on certain information what weight should be for this area, what weight should be. So when we say load is limited, we do not tell, but in designs we consider that if it is this building, is this room is for this purpose, so this should be live load. Live load is actually more important because dead load can't be changed, and dead load means load which is dead and which cannot vary. It's not means there's a death, it's only load that it would change or it would not change, it won't change, but it differs, it results when there's variation in spans. When there is variation in spans, naturally it impacts on structure, and that impact is very much dynamic, not easy. Therefore, we have to think very seriously about structure. People should not be blind by just what they think is right. Sometimes you think it's very good work done, but you do not know what was work done, how it was done. That's only difference here. So my purpose was to just not to worry you, but to just advise you that do not be misled by all. Structure is not that easy. Even sometimes we people, who call ourselves experts, fail in this situation, because if you open codes and read them, it takes a lot of time. It takes a lot of time to read and understand structure, while you can say modification or further thinking on that requires more time. But it is unfortunate that we do not trust that now. Unfortunate it is. We have to understand everything, and like a structure, we have to understand total structure of a building. Total structure. Total structure means whatever members are involved at all levels, these transfer to other levels below. And when we say other level below, means we are on way to total structure. It's like that you have a stool in your home. Stool, you know what is stool, and either you sit on that or stand on that. It doesn't fall, right? It doesn't fall. It doesn't even move until you are stable on that stool. But once you are out of stability, either your stool will fall or you will fall. That's what is called overturning. Overturning means it would fall and I cannot stop it, or maybe I fall, like it happens. Therefore, we should be clear about that. That's the only purpose that I always define engineering. That engineering starts from any point of view, and it doesn't start today. So when I say structural use of building, structure of building, don't be in panic. Structure is very easy if you know engineering. Structural design comes next, but first comes, assumptions. If you see one building and similar building, you'll find a lot of difference in them. And there could be many reasons for that. I don't want to analyze those, because design is done based on information we have. And if you take weight of your building, you will be surprised to know how much weight it has. You can't even imagine. Suppose, let's take an example, there's 100 square meter, or let's say 50 square meter. 50 square meter floor area, 50 square meter floor area in one story. and you have, you can say, per square meter, let us say, you have a load of more than 1 ton per square meter. Load at one floor is, let us say, 1 ton. It should be more actually. Let us say 1 ton, no problem. Then 1 ton, which you can say, including dead and live load, probably approximation 1 ton per square meter. We have to see all these 4 sides of every member, slab member, transfers this load of slab on slab, I mean its own load as well as live load, and that goes on to all 4 sides, and therefrom it goes on to beams and then on to columns. This is mechanism. This is mechanism, and we cannot say it can happen that way. So if you have 150 square meter floor, covered floor, at 1 story, just think of what weight you have. As I say, 50 kilogram, I'm sorry, 500 kilogram per square meter, and I say that per square meter is 1 ton, or let's say more. If you take 1 ton and you have 100 square meter or 50 square meter floor area, let's say 50 square meter case, 50 square meter into, let's say, 1 ton, so it is already 50 tons returns to first floor. If it is 50 tons on your head, think of, and even in your room where you're sleeping in, it may be, let us say, 20 square meter room. As assumption, 20 square meter room means 20 tons is already on your head in 1 floor. If it is 2 floor, double, and 2 floors will double. That's what I came last time to think of. Somebody is come and asking for, but that doesn't matter. So my dear friends, what I'm trying to say is that everything is not what we think is right. You are sleeping on a bed which is resting on load, and you are sleeping under floor which is also very heavy. And if you suppose 3-story building of 50 square meter, so it is 150 square meter, or you can say, let's say, 150 tons or 125 tons for 19. It's essential to know sometime like this. Means it's not that I'm just telling you what's written in contract document. It's not that. It's a question of responsibility. We know that building is very heavy. It's not that light as it should be, but okay, that's true. Now we can say this was just an explanation only for explaining to you what we think of concrete. And concrete is very, you can say, important materials. These the important materials, and when concrete is important means certainly they are relatives like dogs. What can't do? When we jump on to further discussion, we must have basic concepts of what we are talking. I'm talking of contracts. Contract, where contractor does work for you and you have to pay in lieu of that work. Means you have contracted with someone, it may be written, it may be not written. I'm not going into that discussion because that point is legal. I'm confining to representation. Yes, you may be having various all that. Now we'll go to contracts. And contract in its way is very dynamic. Very dynamic in itself, contracts. And contracts means contracting is very significant in engineering because contract itself is engineering. You cannot simply say contractor. Contractor is also an engineer, like a designer is an engineer. Only difference is how you are employed with. How you are employed with, that's important, but do you know what is contract? My point of view is that I go on road and ask people, yeah, I would say, once you decide that you have to construct building, it's not decision alone. Money is also required. So let us move further to understand how shall we construct our structure. How could we construct our structure? That's point's important. Because it is a specialized item, everybody cannot do it. And I know people give this to carpenters or masons, and they do whatever you know, whatever right or wrong for them. They think that's right because they think whatever then is right. Mm. If we talk of real work, where money is involved, where many workers work, national laws do apply or state laws do apply. Question comes in, will you apply? When when we think of making something, yes, if you are not experienced, you will face some problems. But when you appoint some contractor, in duty of contractor, it's also important from where you start. No, you have a contract. I mean, in your mind you have a contract, and you want contractor to sign and work. But what about contract? That's important point. Can you handle it? If you cannot handle it, how can you enter into contract? If you cannot handle it, this means you are inviting troubles to you. First of all, yes, you are a genuine person, you will pay, that's true. But it's not one day job, it shall take months. So, in months, whatever is possible can happen. It can happen, and it happens also. It is construction. Already there is a threat to safety of people. There is a threat of every accident. It may happen. You see, gone are days when people had value of word, value of words. That time does not exist now. Now your documents are not clear well. Forget about your construction. But if you have some construction, you must have some legal contract on papers. What shall you like to contract with? Question is that. How what you say, okay, this is my contract condition. How will you write that? Or you can simply say this is job of this house number. This is party or employer or you yourself. I'm employer of this. It's my building. And you can write whatever information you have. That doesn't make a difference. But let's come to logic. Then you have to write like constitution, dates and this time I said where Contract requires objective. Scope. Contract requires names of party, names of parties. Contract requires consideration that is to be given to contractor for this work, and it requires that you have to be with the project for our times business technique is once we understand what we have to include in contract page, in contract document under process, you also keep in that case binding on that contractor who works for you. Do we really understand how to contract in, or we want to be trapped? That's the important point. Value of documents is very important in our country because of many restrictions and many for communities. Very important point. If you can't understand that, you can't understand that, you can't understand anything. When we move on contract, we give responsibility on our behalf to someone who charges us something and does that job. Because that person may be doing that job for long or for recent, but we accept what that person does, and then that person must give back price of building which was a secured price. EPC it may be, construction may be, or other type it may be. All play important roles. Whatever sort of we do, we have to digest it. We have to digest it and document it. Because it is not one-man job. Many people, many persons are going to work on that activity, on that construction work, and there can be cost, there have mishappen, there can be cases where mishappening took place and you cannot stand anywhere. We change ourselves, we change our style, we change our thinking, and we change a lot depending on various requirements, various reasons. We do that. We trust a person who claims to be a contractor on buildings or structures, and we trust that person, contemplating that that person is expert on that. And representation is from experts only. I am a politician. I don't want to listen to you. Whatever I see, accept. There's a person who was same different. I am a difference. Don't forget that safety issue exists when you plan to construct something. Safety issue means there can be, every activity can result in accidents, even if it's below ground. There should be no. When we say you start some contract document, you have to decide these points before even fabricating that. Amount is important, and sense of philosophy, sense of engineering you have. So you can teach those innocent creatures as well. If they are told, say, why, eh, but contract is signed document. Yes, it is signed document, and it involves all responsibilities that you are the same. Contract is of construction, and it has certain duration for construction, and whatever properties we want we have mentioned. Contractor wants something else, it can demand less. Now, what comes into contract? All these salient points in your home that you are going to build are covered in contract. Shuttering cover, removal of rust, whatever is life in which dust is working now, or maybe more expensive, both. That point requires attention. How do you say that? If I say it's a good construction contract, yes, it is. Your work should be done professional. I'm not saying you can work 100%, there can be few percentage of errors. If you sign contract or give a royal approval like that to the party, both parties have signed. Now it's up to these parties what to do. You have given violation already. So my dear, you have to keep in mind what you are going to do. It's not simply this document shall become ex force if it is not given any in force. So on this page I have made certain points. Pakistan is saying When we work on such contracts, we have to construct and we have to destruct. We have to destruct redundant structures, which use and place we use new structure. When we are saying requirements, contract requirements, these requirements must be mentioned, which we know once some years time shall take to learn these. Long chain of thoughts in my mind pulls me back from your talk and it gives me information to talk of. It's not easy. Improvising your own questions, your own answers is not easy. It's very much effective and effective now, you can say tricky. But construction takes its time. You cannot say I will do it today. Hmm. What do we understand by that contract? That is a document, once it is signed by both parties and witnesses, viewers. That contract must be functional, operative, and stand suitable, stands fit to swim. Well, once you draw these conditions, you draw something that's very important one. If you draw conditions only for construction or your conditions for EPC, both work. In EPC, you are free as an owner from doing anything except conduct transmission of money. When you do this work on yourself, construction contract or EPC contract, you have to think in many ways. Using language is one thing, but using implication of that language is another. This is where it works, how it weighs. That point is important. So I will not now limit to that one. I say objective, you have to set objective in your contract. Or you can say scope of contract. Duration of contract. Scope, duration, these we have to decide ourselves. Then we have to see what sort of, can say, definition of contract in scope of what itself can be included, and what sort of others one. Also conditions which vary according to requirement. Means you have to indicate what is in scope of your as employer, what is in the scope of that person, contract employer. Because whatever construction conditions, whatever design conditions you include, that shall impact on whole contract. That shall impact on whole contract, everything you are going to do. Once you have done that, it's not that you are finished. It means you have started. If you have signed that contract, then there is third party signature. At the same time, So that's right. Let's begin. Let us devise contract and decide about that, how it would work, what's the best way is for it to work. And if you can devise that, we'll find that no problems exist during implementation of that contract. And contractor works, contractor charges payments, and contractor cannot charge payments more than specified lump sum amount, cannot charge more than that and should not until there is extra work you ask him to do. If you ask that contractor to do more than this, then certainly that would charge. But when we say construction projects or turnkey projects or all these, we have lump sum price, which is very important point. Lump sum price means, when you say lump sum, means you have a fixed price contract, which we say fixed price means we cannot change this price, and this is your document that are going to be used for this project, drawings and specifications, and also whatever else that you think should be included. It's better if you prescribe this on documents of this contract, as many as all drawings, all specifications, and you can say whatever else you want, special items, specific items, or other conditions, technical conditions, which grade of concrete, which steel, or in finishing items, which materials may be used on that project, and whatever else, for which all safety issues, which is very important part, safety of workers, safety of everybody, safety of contractors, people, safety of ours, safety at work. All these must be included, which is, you can say, very important point, because if you are doing construction and you are in no way to be safe, then you are at point of danger. Employees you have, workers you have, you yourself, if suppose during construction some slab forms fall, as usually happens, how many people are working there, now building this way, that way. What happens to them? If something wrong happens, that's safety factor we have to understand. If suppose it happens, you are not safe, then means you lose a lot. Accident can happen, mishappen. In that, failure of safety can cost you whole your money, and you can be imprisoned. You can be imprisoned. That point is of utmost important. You are not free. You have to care about safety, about quality, about quantity, and about everything else, quality. You do not think if your money a little, suppose dies, some people lose their life, and you are safe, can happen. When we say everything is safe, we have kept all points into consideration. We keep all points into our consideration, and project moves on. Everything is in writing, amount is in writing, and we have rates also in writing. For example, you want something else other than what is mentioned in the scope. You cannot say for small amount you get another contractor and to pipe, water pipe, yes, heavy, sometimes accident. You have to do it. How should you call them? No, you have gone included, you've gone on a path, you have moved on a path which is explanatory, which is text one, documented one, and in that case, scope of responsibility of both employer which you are and contractor which unknown is. Responsibilities are marked and they have to take their responsibilities that you can convert it to by forming columns and rows on a suitable fine. This this living example very much clear, very much explicit that it will help you. Of course, it would help you. Indeed, it would help you. It will avoid many disputes. It will avoid, if there's a problem somewhere, which it will tell, yes, it is your job, you do it. And you have to do this. Sometimes people don't write. They simply say, believe my words, trust my words. And okay, I trust your words, but in contracts, we don't write like this, trust your words. You define what you charge for this. You define it. Therefore, when I pass through roads I see buildings being constructed. I don't find any safety measures. I don't find any technical specifications people do. Really, those are very challenging one. That people just doing job, they are subject to risks factor, which neither contractor take cares for and nor those innocent people care for. It's question of money, you think, it's question of their survival. But if survival of someone is enriched by life of another one, that's not way. Point lies here. What should we do as employer and what we should not do as employer? What should contractor do as contractor? What should do contractor not do? Once your works are on, it's your duty as owner to make sure that works are supervised. Contractor may supervise only for him, but you must be, if you can afford, you would allow other. All scope that you have in your contract, all scope that contractor has this contract, both can differ. Your scope could be some other disciplines which you are not contracted, or you have contracted, it depends. But quality check must be there. That is another point. Material that is bringing in is significant enough what they are going to build. When you do this, you have to suck out by evaporation, and you have to put water on everywhere by curing, for curing. Quality of concrete, quality of foundation, quality of backfill material, quality of backfill means sorry. It's true. It's true that coordination is very significant on contracts. It's very important on contracts, and we have to worry about that. Coordination. So when I say construction, we do contracts are related to that. It's very much part of construction, documentation, and it's an authority, you can say, when we give a contract. That authority must be genuine and legalized. Legalized in a way, if it's controlled building, it should be, or what we say, something that goes into effect of. It must be considered clearly. We have to understand that fact. It should be understood clearly, positively, brilliantly, what we do and what we don't do, what happens, what doesn't happen, how it works. All are important factors. All are important factors in reality. Life should not be avoided and should not be misconstrued. Whatever is fact and must be taken care of by contractors and by, you can say, by owner, employer, whosoever. That fact is important. That fact is, it has to be functional. It has to be like it works in whatever way we can say. Works go on safe, standardized in every form. It should be according to you can say requirements, according to codes, or if no codes, according to standard specifications, conventional good practice, specification wise, that we do. Safety is of paramount importance. It should be conducted that way. No way it should be deviated, because you are spending money. Nobody is working free, people are getting money. So that money should go to right person in its right way. No way it should be deducted, or no way it should be considered as if someone is doing obligation on someone else. That's not no case here. That's no case here. Everybody is doing its part, playing its part on construction, and it should be safe for everybody. It should be safe for everybody. It should be safe for every point. That's where it is. I can only say that there should be no leniency in any case, no leniency in any matter. It should be right for right thing. It should be right for right thing. And once it is done successfully, it is achievement for everybody. It is product for right. It's product for everyone, for man who constructs it, and for a person who uses it. User and all should benefit, and it is production. It is production, you can say. It's production, and it should be likewise considered it should be likewise considered and it should be respected accordingly. It should be respected accordingly, and there is no way it can't be, it should be, and that's where it works out. Importantly, we can say, importantly it should be. And you know, there's a clear commercial as well as technical you should have. So approach is really, it's a different approach, you can say. Approach, constructive approach it is, or it is, we can say, it is contained in itself. It's contained every way. It's contained in itself, and it is, you can say, it's in our own way dominant. It's in our own way, it's dominant. It should be we have to be very, very careful in its entire mechanism. Well, I don't know what is that. So we should understand this point. Really, in a way, it should be. We cannot take it for granted. It cannot be taken for granted because it's way of life. Because it's way of life, and it should be done that way. Approach is that. Work is work, delivery is delivery, and what we say, right or wrong, that is here to stay with. That is here to stay with, and that is there to stay with. That's approach. Now, building is done, structure is done for everybody. It's not done for one or other. It's done for everyone, and it is to be used by everyone. What I say and what I do, it should be same. There should be no difference. If we do something, it should be for structure, it is contract, it is design, or it is construction. All relate to requirements. If requirement is affected, we can say everything is affected. So requirement is of paramount importance. It should be taken care of. It's of paramount importance, and requirement should be right. It's not, it's like you can say it's like a baby. How you care about your life, how you care about your baby's life, how you care about others. This all depends on. So money you spend on your baby, you don't spend to waste that money. You use that money for good of your baby. Same thing, you have to spend money for good of your baby, and that structure is your baby. If exactly baby it is, because today you are taking care of your baby, you are taking care of your building, you take care of your building, then this building shall take your care. That point is Very, very important. Your building shall take your care when you are taking 2 days care. Your care your building shall take because you are taking its care, and it's really very significant, very important. Your building, which is your baby now, shall take your care for years to come, for decades to come, or you may say your generations to come, it will take care of those. And if you just consider only its material, I think you'll make mistakes. It's material until it is used. It's material until it's only in construction. Once it is constructed, once it is included for permanent use, then you can say this is no more material, but this is a performer. The structure is a performer for you, for your family, for your people to come in future. This gives you support because this is your asset, this is your property. This works for you for centuries or for many decades. For your, you are free mind when you have this structure with you, this building with you, because it keeps on raising its money power also. Of course, depreciation counts in, but practically speaking, and on buildings, on structures, money also counts. Today, it may be some amount. In 5 years or 10 years' time, this amount changes. That point, we must realize that amount changes and we get different aspect. We get different arrangements. We can say that something has happened. This is gone. Building is for you, for its support forever. It's forever. It's not for today, it's not for tomorrow, it's for whole your life to come in. That is true, very much true. You can't change it until you sell it. And even if you sell it, it's yours. Means whoever buys it, it belongs to that. So this structure that was built by you is owned by someone else for upkeep and safety of that family, that person who has taken it from you or purchased from you. But structure won't stop functioning. It will serve you. It will serve that. Because we say service. The structure serves you. First it provides safety to you, then it provides service to you, and keeps on providing safety and service for years to come. You got my point. It's a very important point. For years to come, it provides you that. You should realize this fact. It will provide you base for long time to come. To provide base for long time to come. That's a very important point. Base is provided for long time to come. And your long time not only in lifetime but also in your children's lifetime. So if you cannot care to achieve this long-term support, you cannot spend little time, little care when you construct this. I think you do not do justice to yourself itself. You do not do justice to the requirement of your people in future. Really astounding it is. How? It should support your whole system. If you are having your own house, you have a negative factor out of your mind, that concern of your mind, that you have to spend money for rent, you have to spend money for, you can say, maintenance, you have to spend money to save money so that you can buy a house. You all worries once you have ownership of some size of house, some assets or whatever size, you have this much value of this, and at least from that viewpoint you are safe, that your money, your house is like a bank. You get up, you fix your amount, and it goes on increasing all time. It goes on increasing all time, its value. Same is, I think, bank does not give you that much value, which of course the appreciation exists, but appreciation to exists in valuation of that structure. And today, whatever amount, after few years, that amount is much higher than previous amount. And if you want that, you are very busy, I know, I'm busy, I don't have time. You depend on someone, you don't even spend time to supervise yourself administratively, and engaging someone else technically. You lose credit of your house. If you make a building and say this building, but this building doesn't have quality standards inculcated within this, I think you assume that you got a house, but it's really qualityless house, and it may be valuable, people may consider its value, but it won't give you safety to that level, it won't give you service to that level. There will be distress in coming time, distress in a sense of its structure, distress somewhere else, and if suppose you may get this, you can say, reduction of its durability, so that is another loss. If this structure had to work for 50 years, it works only for 25 years, you directly got 50% loss. It's your weakness, because you did not do well, you did not supervise it well. Suppose you don't do very good curing, let's take for example, curing is not done according to requirement. It's only one point I am saying, or you are using rusted steel in that. So you are just putting, rubbish material, you can say. You are putting rust in your concrete, or you are not taking care of mixing, means you are not taking care of anything. In that case, you are, damaging your baby before baby is born. That point to understand, because in long term, materials do not behave as this used to behave in start, because of stresses on those materials, actions on those materials, heat effect on those materials, variation of temperatures on that material, use of that material, impact of load cycles on that material. There may be hundreds of changes in weather conditions every day, every year. Those material, vibrations on your structure. There is no one reason I can give. There's a continuous reasoning on that. There's a continuation of, impact on that. Soil may not be done correctly. Soil may not be taken care of, which is very beginning exercise activity, and you were convinced by someone who doesn't understand soil. Oh no, it's okay, fine, I've done good. Means not one, not two, there are many reasons. And you don't understand load balancing, you don't understand how to balance this building. Person who is contractor or who you may call builder, that person is not interested in anything as such. That person is only interested to erect your building only, without considering anything otherwise. I've seen people use columns, say, which is just 9 inches by 9 inches or 9 inches by 18 inches, let us say in your language, in your terminology. And you are happy with that, while it's not correct. It's not correct. Minimum dimension of column should be 1 feet, 30 centimeter. But you're doing 9 inches. There is a reason for that. It's wrong that according to you know height of column should be 12 times minimum dimension of section. So if you are say considering 9 inches only, this means your height of floor cannot be more than 108 inch. 12 into 9 inch, this is 108 inch, which means 9 feet floor height or floor to floor height. And generally people keep floor height or floor to floor height, that is 10 feet and 6 inches. So already you have lost 1.5 inches dimension there. It's given instability to that extent. In place of 9 feet, you are giving 10.5 feet, so 1.5 feet more. 9 feet and 1.5 feet, so this is about 15 to 20%. Instability factors already come in, and that would try to buckle that column to some extent. Buckle means what? Cripple, you may say. It's movement in a horizontal way. So we have to understand, and moreover, so in that case you can say it's not actually ordinary column, or we can call it short column. You have extended column to long status, long column. So stresses which we take into our calculations about concrete and about steel, those must be reduced. So this is reduced design. Means you're not getting advantage of column that you should get. Another point is our structure should be flexible. When we design structure, we consider that this structure shall work flexibly and as unit. Now, what is meaning of flexibility in ordinary language? That means there are many joints in the structure, all in the slabs, in connection slabs and beams and columns. All these are called joints or nodes. Every junction, every joint where beams and columns meet, that's called joint. Every place, and where slab comes to beams, it's also same. So this is called joints. And minimum, let us say, every floor there are many joints. If, for example, we say, suppose there is a 4 bays of slab, which means there are 9 columns. You can say there are 9 columns, 3 and 3 in that portion. I'm just giving an example. 9 columns are there. This means there are 9 joints. These 9 joints in one floor, and let us say you are 4-story or 3-story. Let's take up 3 stories. This means in 3 stories there are 27 joints, and then at foundation. So these joints should work together. That's what structure requires. If there's action on one floor, that action is transmitted to all other floors below, of course in proportion, not exactly same, but this should transfer in continuity. You cannot say that suppose there is a break of continuity at any joint, it is harmful to your structure, and your structure then does not transfer force at that joint how much it should do. So it causes inability of that continuity and that load transfer. that action transfer. That point we must understand very well. And moreover, it's not you are reducing flexural stability, then people it should be free to move, your structure should be free to move. More flexibility means light structure, and light structure is better, and more flexibility means movable structure, and a structure that's like having elastic properties in that. It says elastic means when you expand elastic, it comes back to its original position. But if it's not elastic, it's like a rigid. It's a rigid, it's difficult to move because you place in walls before slabs done. You raise walls, and then you abuse walls and use columns in between walls, and you increase rigidity of those structural walls. So in fact what happens, you increase grip between columns, surface and walls. You increase grip between wall top and slab or beams. So you reduce flexibility of that frame. Your frame should be separate from walls, but you do not understand, and you actually frame a fall. You frame a fall means you frame of your column beams along walls, and that's where problem lies in. Wall is not equivalent to RCC. Wall is very little strong, but you are not clear about this because of time saving, because of concrete saving, because of having low confidence in your structure framing. You spoil all efforts of design. I have seen such construction in everywhere. People do this. I have seen many people who don't do this, but people generally do it. When people generally do it, it's not, it's not, you can say, becoming, it's not becoming status. We do not understand something and we take it only as we like it. It doesn't work. It doesn't work. But people say it works. That's the only difference. We have to keep it clear in our mind that it's not right way. It's not right way to do as such. We have to be very serious because it's issue directly related to everybody, partly for your building, for a house. Yeah, I'm not talking, you're not going to make flyover, you're not going to make railway lines, you're not going to make water lines, sewer line of roads. So it's at least your home. You don't worry about design of architecture because that can be adjusted, but structure is not in hands of anyone. Even engineers can't change it. A structure is something very difficult component of building, and if a structure is not made according to, we do not understand how structure should be, and only engineers can think this, and that too also with restrictions. And basic principle is that we have to reduce moment of building in either direction. Moment means you can't visibly reduce in millimeters actually. You cannot reduce it. We have only way to apply methods that can contribute to reduce those deflections, those moments or sways. When we think that if I'm standing somewhere, for example, you take yourself to stand somewhere. If you stand stably, just like in vertical position, and you don't feel tired, if you just keep yourself in asymmetrical position, take some turn vertically or horizontally, after some time you feel that you are not having that comfort of physique of body because you are now out of balance. And that's what I'm saying. Out of balance means, let's say, some eccentric load on your body, and that's what applies, this happens to buildings, to structures. Means when building load, or you can say total load of building, there's some point in building where that load passes through, which we call center of gravity of that building. For example, let's say, suppose I say total load of this building is this, which will be there. So size of building is there, load of building is there, and there is then dimension of that building. This is load center, total load center, and then there is dimension of building, and there is a point also based on that size of building. Means where all areas converge. I mean to say that point is called it. That point which is central point of total areas, and point where loads come in, those points should be almost same. Within some tolerances, you can say you can take little percentage out in, but that point, and not only horizontally, in vertical position also, that point grants stability to building. So size of building, dimension of building, arrangements of structural framing, everything must be kept in consideration. Blindly we cannot do anything. It's not simply that we do ourselves, we can't do ourselves also. Civil engineers also, or structural engineers, they have to think a lot in that. Means asymmetrical pattern of design leads to, out of line loading. Size and load do not match. So that situation should be avoided. And that can be avoided by many methods, which no need explaining now, but this requires attention of engineers. That's why I'm saying it's not simply just designing with complete consideration. For you it may be only shuttering and beam and column, but for engineers it's not simply beams and columns, it is complete stability of structure. Means we consider from point to point, from corner to corner, and then take out how much load comes on from that slab, and first how much load on slab, then from slab to beams and columns, and then continuation of that vertically. So these points very important to understand, and if you can't understand that, you see you can't design anything. That's an important point. It's very basic point actually. It's not only important point, very basic point that we have to avoid eccentricity in building, not only in whole building, in whole members of that structure, and then that eccentricity. Eccentricity means non-axial forces. Means, for example, if I say this column is, you can say 1 feet by 1 feet, then load on this column should be at center of that 1 feet by 1 feet. But if it doesn't happen, it goes, let us say, 6 inches this way or 6 inches that way, or 3 inches this way or 3 inches that way, the load comes out of column or out of center, and that's where problem lies in. Same thing as you can say, I'm standing on 1 foot and I take my other foot up. So how do you feel in that case? In this means your body load shall pass on to that leg, that foot, and you will feel tired after some time. I've been standing on one leg for half an hour and I'm now broken. Same thing building does, and this is from top to bottom. Framing is done, and if you have done that, you cannot touch it as well. Or if you had made some provision during casting itself. Provision means there are Rebars problems are there. Rebars in doubles, we call them towels. If you want to keep in future that in future I'll extend this portion up. In that case, when the concreting the portion, you have to keep certain towel bars for future expansion, and you keep in mind also that expansion and design accordingly. So there means expected moments, expected loads, expected deflections, then all this must have been considered at that time, and you make provisions in old structure. If you have made, okay, you have way to go enough, but if you do not know, then you cannot break concrete and put in steel. That's not very, lucrative. So my point of view is that we have to be very clear, because I don't know, people are so courageous to violate safety, to violate engineering design. They are very courageous in that approach, and that approach takes them nowhere. That approach takes them nowhere, and it doesn't do any good for them. That point I had to mention here is really important. And you know, I had no intention to scare anybody, because people will not tell you all this. I'm just telling you because I have seen this happens. Buildings overturn, it happens very many places of world. This happens in our country. They say cracks are coming in, building is little moved, what to do? But when we do building at that time, no one cares, because everybody is interested in money, fast money making. They forget that building has been considered as commodity for many, is make it, sell it and earn money, and let person who buys it suffer. We do not think of occupants actually, we think of money only. That it is a it's good as such that once you have, you sell and make money. Like that, some people make business. It's not bad, but if it's engineering wise safe, I think in that case it's fine. People do not really understand what they should do, and that point is worrying some. We have to be worried about that, because people are very strong in taking risks. Unfortunately, those risks are not those risks are not not encouraging. Nobody can encourage for those risks, but people still do that. That's very, I can say, unfortunate in our approach. Very, very unfortunate. We do it and we do not worry about that. It's really very, very sorry statement I'm making, but we only consider money, we do not consider something else. That should not be point. We have to be careful, we have to be visionary, that I'm spending whole my saving of life for my building, and I leave it to someone who is not interested for good building, but only as money making. This point we have to clarify. Okay, you are running the site, you are doing job, but past jobs you have money with, maybe from parents, someone's, you are spending on this building. It's like you are spending on your baby. You take care of your baby. You might not have spent on your baby that much, you're spending on this building. And this building shall serve everyone of your home first, and for that result, you're not interested to look after this building. That's a point of engineering failure, I can say. It's nothing but engineering failure. It must be avoided, and of course it is little annoying, it is little disappointing, but it happens, and there's no way out, right? You have to be clear, you have to be careful about this. I did not want to tell, I did not do anything on explanation of contracts. I just tried to first let you understand why I'm stressing that much on contracts. Construction is a field. It's not ordinary world. It's a world where material in extensive form is used. Human resources are in extensive form is used. Equipments are used in extensive form. Whatever is used, that is used in extensive form. Money means when materials are using money, you are spend, you do a lot in that. But if you think that you don't have those skilled people, those high version skilled people don't have, that point brings something undesirable. I would explain further later on about contract. I just want to give you something very preliminary, because I know nobody shall like to have more stress, more tension, but it's for future. It's for future and coming time. You have to see this. Actually, if you understand this point, you can understand a lot. Remember, concrete or RCC, if not done consistently, competently, not done according to requirements of specifications, not done according to what engineers used to think. You can do it physically, indeed. Physically you can do it, but mentally it's not done. I know people say, who takes botheration? We don't have time, we cannot bother. Okay, you don't have time, but if suppose something happens, non-desirably, of course, who shall face that problem? Who shall face that problem? If something happens undesirably, who shall face this problem? This problem shall be faced by those who occupy that building, that structure. They shall face this problem. And if they face this problem, means there can happen whatever. If there's a distress in that building, there's a movement in that building, there's no solution. I'm not saying that it will collapse. I'm not saying that until something happens wrong. Because material which used, material was excellent, but mixing was not excellent. And reinforcement placement was not excellent. Or you placed reinforcement which was junked or rusty. Or there was some other problem. And you did that. The undulations on surface of concrete, vertical as horizontal. There were, honeycombing. There will be many other faults we should not accept. To that point of view, I can say we have to be very, very careful very, very, concerned, which people are not say, okay, we got building, we got roof above us, and that's fine, the satisfaction criteria for them. Temporarily you have roof, but permanently you have a problem. See, brick can be removed, brick wall can be replaced by whatever method, but concrete and frame, in addition to concrete, if framing is your building, remember, framing cannot be changed. Framing cannot be changed. You cannot change work done. You cannot change. If it is right or it's wrong, you cannot change. You can break everything that is spoiling something else, but you cannot keep building safe under preservation. That's point where is a concern about. We have to see this actually very important point. We have to see in. It's really very important concern wise. So I think I understand that you may be getting my point or you may not be getting my point, I don't know. But you should get this point of concern. Really speaking, you should get this point of concern, and we must be serious about that. Must be serious. And if you are not serious for your building structure, for your own, for whom shall you be serious? That's the point here. For whom shall you be serious? You shall be serious for none. And do you want at a stage of serious for none? Today you may have to spend some time for this building or structure. At least the structure, I am saying structure, not building. Because for me, structure is more important than finishing items, because we have good machines for finishing, no doubt. They can do finishing if you instruct them rightly, but we don't have good people for structural work. They do only what they learned, which is not right. They did not learn from engineers, they learned from by their people, own people, or by architects or through architects. They're learning. We don't have skilled craftsmen, skilled technicians for structural work. Whoever are they are learned all mistakes, they learned all wrong, and they think they're experts. Well, I'm not going to say you criticize them. It's not their fault. It's fault of society, it's fault of system. They have to live, they have to make money. But training, they don't have. They have training only from their parents maybe, or from working with some same type of worker. And that person or class doesn't understand anything. So you cannot say that is their fault. But engineers also should care about this. Engineering should not be killed in beginning of its start. And if we kill engineering, we can say we kill, what I should say, we kill our money. Money which should be used for something else, used for building, for property. It's not that you use just for running money. Somebody has to use that property ultimately. You are also using some property which is not engineered one. Property exists, but it's not engineered one. It is just constructed of illiterate people, illiterate intellectuals. who have no knowledge about engineering, they do it. And that's really very big concern point. I always think that way. You may not agree with me, I can say, but your agreement or no agreement, I'm explaining my option, my mind. I'm making presentation of my mind to you, what it's all about. Well, I think I should not close it now because it's now over and we should go further. We should have closure now, in this case, and it's already, let me do it. I think I'll take leave now. We'll talk again.